G'day, my name is Greg. I am a CNC hobbyist who has a home-built CNC plasma cutter. I made a video about how I produce G-code for that plasma cutter using Vectric software. However, YouTube analytics tells me that people who are watching it are dropping out after a few minutes, which tells me it's just too long and boring. So this is my attempt at a more concise video on that subject. Okay, producing G-code for CNC plasma with Vectric Cut 2D, VCarve Pro or Aspire. Here we are in Cut 2D, which is the base or entry-level offering from Vectric. It doesn't matter what level of software, they all have exactly the same capabilities as far as what I'm talking about today. There's two main things or two aspects or two things that I need to do to adapt it to Plasma Toolpaths. The first one is I need to go into the tool database and create a tool that represents the plasma cutter. Now there's no specific plasma selection here. What I do is I select an end mill and I make the diameter of the end mill to be the width of the curve or the cut. Pass depth I make a millimeter, it's almost irrelevant. Step over is irrelevant, spindle speed is irrelevant. Or you can't actually add zero or reject it, and the feed rate matters for the material that I'm setting this up for. That is the suitable speed to cut at. So that's how we set up a tool to represent the plasma torch. Now CNC plasma users may be asking, well, what about pierce height and pierce delay? We'll get to those in a minute. The second part of what I need is a post processor, which tells Cut 2D how it wants the G-code set out to suit a particular machine, controller or application. Now the easiest way I think I can demonstrate that is I have just here a line. I'm going to create a toolpath to cut along that line. I'm going to set the depth of cut at 1 millimeter, although that is almost irrelevant. I'm selecting a tool. I'm going to select my 1.2 millimeter tool. I'm going to cut on the line rather than inside or outside, which most jobs would be cutting on the outside of the line. I'm going to cut on the line. A lot of jobs I would add leads or lead-ins or lead-outs, not in this case. I'm just going to calculate that, and here is the visual representation of the toolpath. It simply starts the cut at the beginning of the line, which happens to be the XY origin, travels to the end of the cut and ends the cut. So I'm going to save that out using a post processor called Plasma Millimeter. This is my post processor that I have written for this purpose. So I saved that toolpath out. It's already there, and if we look at that toolpath in a text editor, here it is, about the simplest and shortest G-code toolpath that I can create. First line here simply moves the torch to the beginning of the cut, which is in this case the XY origin. Then at the beginning of this and every cut comes this piece of code here. M12 is a little macro that does the touch off, which finds the surface of the material, sets the Z0 at the surface of the material, and then retracts to pierce height. M3 just turns the torch on or begins the arc. M13 is simply a little macro that calls a delay for pierce delay. Then the torch moves down to cut height and immediately starts the travel along the toolpath, which in this case is only one line, but more often than not it's many lines, even hundreds, even thousands sometimes. At the end of the cut we have this section. M5 simply turns the torch off, and then we raise the torch to a clearance height of 10 millimeters to move to the next cut. Now in this case we don't have a next cut, but very often you'll have this repeated many times with the cut as required in there. Then at the end of the code we have this bit. We just raise the torch to a height that I find suitable, and return it to X and Y origin. M30 simply means the code's finished, rewind. Okay, so the post processor to achieve that is here. Well, this is my post processor. Now when I want to write a post processor for myself, I simply just grab some generic post processor from the database, from the selection that's provided with Vectric software, and make a copy of it and then just alter it to however suits me. Now probably the first thing you'll notice is that I cut out a lot of junk. I like my code to be as clear and easy to read and uncluttered as possible. I don't need to please everybody like Vectric does with their official post processors. I only need to please myself. So I cut a whole lot of guff out. But what is important? Okay, here is the name of the post processor that came up when we selected it within the software. Text is just the file type that I select. Millimeters is the units that I work in. Many will work in inches. The other thing that is important, or the next thing that's important, is to remove every reference to the z-axis. There's generally a line here. There's generally a reference to the z-axis here. In all of these, I just go through and remove every reference to the z-axis. Clockwise moves, counterclockwise moves, and then we get down to what's called the plunge move. Now you'll notice that this is what happens at the beginning of the cut, and it simply places whatever I put here right here at the beginning of every cut. Then we move to retract move, simply places here whatever I have there at the end of every cut. And it's really that simple. This of course will vary according to your controller or your requirements, and so will this, and I guess even so will this. But this is what I need to do to run my machine. The footer just goes there and comes at the end of the cut. Alright, now just a little explanation as to why I use these little macros M12 and M13 which I have written. Here we are in my control software, which is UC CNC. That piece of G-code is loaded up, ready to go. And just for explanation, M12 is a little macro that does the touch off and then picks up this value here. I can enter any value I like there for pierce height. So that's how the macro knows what pierce height is I've set as being suitable for that material. Then we move down to M13. It picks up the value of this field, which I can enter any value I like to represent the pierce delay. So that's why I use those two little macros, M12, M13. Other machines, other users will do this different ways, but that's the way that I choose to do it, and that's the way, the reason that I do choose to do it that way, because this is where I enter pierce height and pierce delay. Okay, well, if you've watched as far as this and you're interested in any more details, you could search YouTube for Vectric Plasma and you'll find the longer version of this video. I hope it's been helpful to someone, and thanks very much for watching if you've lasted this long.